Welcome to another electronic video. Okay, I've started on the LEADER oscilloscope that I got from Don. A couple of issues here. First of all, I got the top and bottom off, as you can see. These are the vertical positioning knobs for both the A and B channel. Somebody had put in the wrong screw. It was jammed in there and it was holding the knob on, but it's not the right screw, so I may have to scrounge around for another knob or a set screw or something if it'll fit in the threads. Of course, this is the LEADER LBO-308, I believe. 308S. Damn eyesight. Okay, I had removed the knob. This is the one right here. Where am I here? Right here. I'm holding this right now, as you can probably realize. The lower knob, which is the B channel, works fine, but that's the one that had the messed up set screw. Now, on this assembly, I think the whole assembly comes out as long as there's no nut on the back of this and I have to remove this panel. I will not do that. I will live with it. So I'm hoping that this whole thing comes out without any nuts on the back, and I don't think there is. What I'm doing here is I'm loosening these screws. This whole assembly, as you can see, goes right to the other side. Over to here. And it plugs in, so it's on a board. So if I remove these two screws on this side, this whole thing should slide out. If that's the case, I will be all set. Now, Don says it's a loose connection, and I agree with him. I can power this back on, but take my word for it. The A channel, up and down, will rotate completely one way to the other. There's nothing that don't feel bad in the potentiometer. However, the trace will stay in the middle and in full rotation will go down and up, but never up here. It'll stay at the middle or down and back up again. If I take, of course the knob's got to be on, if I take and hold this up and then turn the control, I'll get full movement up and down just like I do with the normal working B channel. Okay, so upon examination, looking up, you can see a printed circuit board there. I'm hoping there's a break in there, and I'm sorry I'm shaking. I'm holding the oscilloscope up and I'm shaking a little bit doing it. So what I'm going to do is I'm going to loosen these screws up, but not take them out until I make very sure that this whole assembly with the push buttons will come right out. Be right back. It looks to me like I loosened these, and you can see the knob wiggling, so I doubt very highly there's a nut on there. In other words, these controls are mounted to this bracket here, and the bracket and the push button assembly will come right out as one piece. Whether I can fix it or not, I don't know. So let me get that out and we'll be right back. You know, I just noticed I'm not going to go poking in there with anything metallic. It's turned off. Of all the years that I've putted around with oscilloscopes, I've never seen a deflection coil. And I don't think that's a deflection coil, but they don't use yokes in oscilloscopes simply because you're not going to have a very high bandwidth. You know, you're limited by the coil that's around it. Televisions, yes. Oscilloscopes use deflection plates, so I think that this coil here is maybe a degaussing of some sort. I don't know. But anyways, let me continue taking this out, and I'll do that off camera. I can work better off camera, and if I succeed in getting this out and unplugged, we'll get to look at it. Okay. Now, if I can get this unplugged there, there's a plug on the other side of 2 wires. I'll do that off camera. I put an X on here so I'll know what this is the control that's when I hold it up. It behaves like the circuit board is messed up. And you know, I think maybe I'll try to solder that the way it is. It don't look like this. Where am I here? Damn, I'm always off camera. The parallax error really gets me on these type cameras. I don't see any traces on that side. So, as you can see, there's traces here. Oh. Now, if I insulate this, and I'm very, very careful, I could probably try it like this, but I think it's too risky. So let me get my microscope eyelope out, and I'll check that out. I can't do anything when I got the camera here. Well, that came out very easily. What was happening here is it was hanging up on these red and black wires here, which went to this coil. So we'll have to tape those down somewhere. Okay, so the part of the board to control that's bad is right here. There don't seem to be anything on this side. So what I can do off camera, of course, is I'll resolder this. Now, this is the good side. This is the B channel. I could be wrong, but this looks original, and this might have been worked on. Okay. All right, let me spend some time on this. I'll be back. All right, I got them out. I mark them because this has got 3 wires on it, and this has got 3 wires on it. So I marked this one 1 and this one 2, and we know this is the middle one. A little tricky. I wasn't quite sure how they came out, but I guess I lift that little... Where am I here? I'm off camera again. Okay, so the rest I'm going to do off camera. Okay, I did the best I could. I soldered each one of these, and even this, although this was just a bracket. It looks like there's some solder down here. I don't know if it's showing on video or not. Looks like somebody might have added some solder here. So it could be a broken trace. I could connect the wire from here to here. But I think what I'm going to do now is I'm going to... The leads are long enough, so I'm going to put them outside the scope. And very carefully see if it works. I think, yeah, this has got to be grounded. Off camera again. This has got to be grounded to the shell. So I'm going to do all that. I'm going to hook it up with some clip leads on here. I'll put a couple of clip leads on the ground and connect it to the ground rail here. And then plug these back in, and let's just give it a try and see if it works properly. I hope it's not the control, because that would be almost impossible to get. It's a little hard for me to work on, but fortunately it's accessible, and that's important. Be back. Okay, the scope is sideways. We're going to flip it on now. We got the board insulated from this scope. We got the board grounded and plugged in. And we'll give it a minute to warm up. I'm going to have to get my head in the way here. The focus is out, of course. We're picking up a lot of, just getting through 6 inches away from the circuit board. You can see how sensitive it is. But let's all right, this is the A channel. It's working perfectly. Now, let me grab that control and move it around. I think we're okay. Alright, it looks to me like I think we fixed it. The only thing I will do is put it back in there and see if it's going to stay working. Alright, I got the panel in. What a job getting these buttons to come through. Alright, I didn't put the knobs on. Now, you're still going to get a wide trace because I got the case off of this. So it's going to pick up all kinds of interference. But I'm concerned with the trace. The A channel is working good. Channel 2, it's a B channel, that's down here. That's working. Back to channel A. That's picking up a lot of, like I say, a lot of interference, which should not be doing that once I get the case on. Now, I can shut it down to ground. We'll leave it to ground. Alright. It looks like I fixed it. Let's see. Dual trace. Alright. Okay, is channel A. Very hard to turn this without a knob on it. Is channel B. Okay, we'll turn it off for now, and we'll come back on this in a minute. Okay, well, let's try it out. It's all back in the case. I'll have to admit, of course it's upside down right now because I just put the bottom on, but the only problem I'm having here is the set screw for this knob here is messed up. So I got it upside down because this is the B channel, and this is the one that had the bad set screw in it. The set screw goes in, but it sticks out quite a bit, and don't look too good. But it's not what I want. Can't see the screw slot. The glasses just don't magnify enough. Well, it sticks way out. You might be able to see that. It looks like hell. I'm going to put a different knob on that. I'm not using that. I've got an extra gray knob from a box of knobs I had a long time ago, and these knobs fit the Tektronix scope. You know, if this scope had been a Tektronix, as far as I'm concerned, in my opinion, are non-serviceable. When can you take out a board like you can on this one here and be able to disregard that black mark on here? That was put on another piece of equipment that he had, but at least we'll have a good knob on there. And now we've got the good one, which uses a little larger Allen wrench. So I think I'm still recording, as I know. As far as I know, yep, I'm in screen. So where am I up here? I'm not going to worry about the pointer too much, where it's pointing to. Just lucky to get it on there. Okay. Lucky to get it on there. Never mind trying to rotate it to a different position. Alright, so we got a bigger knob down here, but at least it doesn't have a screwed up set screw on it. This stuff is just too small for me to work with. Alright, scope is plugged in. Let's turn it on. And we are on AC coupling. Now, we were getting a lot of interference because we didn't have the case on it. We should be good now. That's the A channel. That's the one that was not working. This is the B channel. So we're looking good. Might have to clean these switches with a little bit of deoxide. I'll just spray in there. No biggie. So, left and right. I think we might have a dirty control here. On the horizontal positioning here. So let's stick a cable on. I've already checked out the channels on this. We'll go into the A channel. We're just using a simple lead here. Now we're just on the A. Let's see. Dual. Let's short that out. Trigger control. I don't know what we're getting in here. Let's see. So all right. That's the A channel. It's the B channel. All right. See if the battery's still good. Yep. All right. We got 20 kc going in here from the function generator. Let's flip it over to square wave. You got to use a calibrated probe on that. Sawtooth. Sine wave. Okay, so this is the sync control. See, we lock it into sync. And this horizontal positioning. Now I'm going to have to turn you off camera here because my neck is killing me, twisting my head around. What 0.2 volts per division AC coupling in the calibrated position here. 0.2 volts per division in the calibrated position here. All right. Let's get that. Okay, we're in channel A. Push buttons in for channel A. We're set for 10 volts per division. We got the attenuator down to 10 volts per division. We've got the baseline. There's the center, as close as I can read. My neck is killing me. I'm hunching over like the Hunchback of Notre Dame. I'm going to have to hand hold this, I'm sorry. I had to put the lights out in the shed because there was too much glare here. And sticking this scope up here like this, I had to set the rotation control, which is screwdriver accessible right here, because the trace was rotated. Okay, now, as close as I can tell, my neck is killing me. I have more problems. My back has been bothering me, just aching from doing different things. Okay, we've got our power supply set. You check your volts per division with DC, because when you're reading AC, you're reading the peak-to-peak voltage on an oscilloscope. So we're at 10 volts, and this meter is pretty much spot on. I put digital meters on this power supply before. She's spot on. We're connected with the coax going out here. Okay, we got the input to ground right here. We've got our baseline set right here. You can set it wherever you want to set it. You can set it here, you can set it here, it don't matter, as long as you got a reference point. So if we're accurate, when I flip this switch to DC, because remember we're DC coupled, AC coupling goes to a capacitor. Of course you cannot read DC to a capacitor unless it's leaky. So if I flip this down, I'm putting in 10 volts. This should go up 1 division. And as close as I can tell with my bad eyes, it seems to be about that. Let's check channel B. Okay, we're on channel B, or channel 2, whatever you want to call it. We'll flip it down to DC coupling. And she should go 1 division. And it's exactly what it is. Okay, so in that respect, it's right on the money. But with no input in here, and your input's set to ground, when you rotate this control, your baseline should not go up or down. If it does, your DC balance is off, and it is usually an adjustment inside. Some of your scopes have them outside. Some of my older scopes, I adjust them, but there's no compromise. One's scales off. Sometimes you can successfully set them and other times not. Okay, let's get back to what we're doing here. Okay, so, hang on, I can't see what I'm doing. We now have our vertical input calibrator set to 5 volts per division. Okay? Your red knobs are in the cal position. They must be left that way as if you're checking amplitudes. You can vary them, but if you're trying to calibrate something, they got to be in the cal position. Okay, so now with 5 volts per division, we should jump up 2 divisions. Close as I can tell, the camera shows a very bright image. Okay. All right, now let's go to channel A. Let's set the baseline right on the graticule in the center. We're at 5 volts per division. We should be jumping up 2 divisions. And we are. So the bottom line is, it seems to be good. I don't know how to calibrate or check on the sweep. In other words, I can't measure, I don't know how to measure frequency on an oscilloscope. That's something that's beyond me. I got to rest my back. I don't know, my back is bothering me. Muscles, not joints. So anyways, I'm going to end this video. The scope I'm very happy with. I had to put a block underneath there because it was pinching the power cord. I had to do it that way. Let me get this thing back down where it should be. Okay, we'll get this brightness down a little bit. Because I had it standing up, oscilloscopes are usually sensitive to where you place them. That is why you have a trace rotation control. So we got to get that baseline straightened out. See how that goes? Okay? So you get it close as my rotten eyes can see it. It's straight on the baseline, so it should be equal. I'll fine tune it because I need to get my eye and a magnifying glass right on top of the graticule. I'm going to say this is fixed very well. Here is the vertical positioning control. You can see how that is? There's still a little movement, but I'm able to get it right where it should be. Now we go to channel 2. And it does the same thing when you press on it. See? we get a good rotation there. We get a good rotation there. So, and we got a dual trace. Okay, folks. So I can say we definitely, for the first time in quite a while, I was able to fix a scope. As I said, and I stand by my saying, I believe that Tektronix scopes are not made to be serviced. A Leader, on the other hand, you have much better chance. I'm not saying it's going to be that way on all Leader or other equipment, but on this particular one, you can see, for somebody like me with got rotten eyesight, was able to get in there and do it. Tektronix, no way. They're not made to be serviced. Thank you for watching. That concludes the video on this. We'll be working on this probably maybe tomorrow. We'll see. I got a video I got to put up now. By the time you're watching this, you've already seen it. Take care, everybody. Thanks for watching.